Hey everybody, I just wanted to give a quick video demo of a project that I've been working on over the past few weeks. This is my homemade Dobsonian telescope. It used to be a Zoom LZ12, but I took all the optics out of it and built this nice little base for it. It's not a truss, it's a strut Dob. It has 4 posts. And that was just to make it easier to move around. But anyway, I have on it the sensors from Romer Optics to be able to make it a push-to. And you can see that sensor down there. So it keeps track of where the telescope's pointing. But my newest addition is adding motors. So I have 2 stepper motors, one for the azimuth, one for the altitude, which is mounted inside like this. And I'm going to show you how this works. Let's see, turn on the laptop. Alright, so I'm going to start up the push-to plug-in. And this is connected to Stellarium. Set my time zone. DST, not that that matters, indoor. The push-to is connected to COM port 3, so I'm going to turn that on. So now you can see as I move the telescope, I'm seeing movement on there, so it's tracking. It's way off right now because one of the sensors is mounted at a severe angle. But the star alignment will take care of that. Turn on the Stellarium connection, and then I can minimize that, and we'll run Stellarium. So this is not a guide on how to set up the connections to Stellarium. There's already videos from Romer Optics that cover that. I'm just going to show my latest additions. Get out of full screen, but quickly I'll show. I have a telescope set up, and this is connected to the to the plug-in. So we'll get out of that, and now if we look around, you'll see, where is it? Yeah, can't find the pointer, but anyway, this is a script that I created to help me find that little reticle for the telescope. So if we run that, and then when I click on the star, okay, something's not working right. What's missing? Not in real time. Did I not start the script? It is running. What is not working? Alright, give me just a second here. Let's go back to the plug-in. Make sure this is still working. Yes. That's on. Yes. Telescope is stopped. Start that. That's because I hit the edit button on it earlier. So now then, with this script running, these numbers here, oops, I'm not even pointing at the screen, sorry guys. Well, since I started the video this way, I'll keep it this way. These numbers here show me which direction to point the telescope. But right now we're not star aligned. We're going to fake it. So I'm at about 45-degree altitude. Let's see, that's 40 degrees. See what else I can find. It's close. Nothing. Alright, we'll use that. we'll say I'm pointed at 40 degrees, and I'm going to do Control 1 to do a star alignment. That'll move the reticle up to the item that I'm pointing at. So now when I move the telescope, you can see the telescope indicator moving around on the screen. So now we have a push-to, so you can line up on whatever star you want, right? All right. Now the second part of this little project, since this script can tell me which direction and how far to turn the telescope, well, I decided to have it output that to this other program that I wrote. And let's make sure our motor batteries are turned on. And let's say I want to go look at Rigel. Enable tracking, and the telescope begins moving. And it's trying to zero in. This is the altitude, azimuth. And you can see on screen that we are now pointed at Rigel. Now let's go to Betelgeuse. I'll just keep it here, and you can see the telescope is moving, or at least the indicator for the telescope is moving. I have a little tweaking to do on the software because it slightly overshoots, and since we only did a 1-star alignment, when it moves, it kind of moves at an angle. I really need to do a 2-star to make sure, because I'm sure I'm not level at all on the base. So now we're lined up on Betelgeuse. Let's say I want to look at Venus. We'll go over there. And the telescope is now moving to Venus. So, with the Romer Optics and this custom script, I now have an EZ-Goto telescope. And what's more, as the sky moves, or more accurately, as the Earth moves and the sky appears to move, this will continually update and take steps to recenter the star. So it will track the star as well. I don't think this will be good enough for any type of astrophotography. One, because of the field rotation, obviously, but two, I think the steps will put too much vibration in it, and many of the frames will end up blurry. But I may give it a try anyway and see if I can do like hundreds or thousands of very short exposures. And I don't know if the stacking software that will throw out the blurry ones and just keep the good ones. I don't know. We'll see. But that's a future project. But right now this is working pretty well. And that's it. So when I get some time, I'll do a little more in-depth maybe on how everything was put together. Well, I can quickly show you a couple of things here. So I have one stepper motor that's attached to the bottom of the rocker box, and I made the gear in the bottom, in the baseboard, using epoxy putty. So I used a router to cut a smooth groove all the way around the circle, and then filled it with epoxy putty. This particular one here is called Milliput, and I pushed it in all the way around, let it set for about an hour so it wasn't as sticky, and then set the rocker box back on top of it with the gear already mounted. And so the gear pressed into the putty, and then I just spun it around in a full circle, and the gear itself made the track, the teeth mark for the bottom gear. I did the same up here. You can see on this bearing here, I just coated the outside edge with the putty. This one is called Magic Sculpt. Wanted to try something different. I made some little channels in the back of the gear just to kind of help it hold there. And then set the rocker box back on there with the gear mounted and did a full 0 to 90 degree turn to make those teeth in it. Let's see what else. I'm using a stepper bee board, but I've just found out that the stepper bee is limited to 0.5 amp per phase, and these motors actually draw 1.2 amps per phase, so the stepper board gets kind of warm. I have heat sinks on it, but it also, since it's not running at full amperage, it doesn't have as much torque as it should. So I'm going to upgrade that to the Stepper Bee Plus that can handle 6 amps, and that'll should at least double the amount of torque that I'm getting. For the base, the amount of torque doesn't matter. I used the roller bearings from the original Zumel Z12 base to greatly reduce the friction instead of using the Teflon pads. So the base can spin around all day. It doesn't really need much torque. But this one was having a little bit of problem once I put my eyepiece in, being able to lift it back up. So I added some counterweights. That's what that counterweight up there and the 2 clamps was to add enough counterweight to counteract that huge eyepiece up there, and now it's able to go up and down. But I don't want to keep switching out counterweights all the time. I'd rather it be able to handle a little bit of imbalance on its own. So I think that's about it. I have a really long USB cable tied to it to connect to the laptop, because the laptop will be sitting on a table and don't want people tripping over this. So this is a glow-in-the-dark cord from Harbor Freights that I braided around the USB cable. And it's a 16-foot cable, and hopefully that'll be enough to keep people from tripping on it. Anyway, I think that's about it. Thanks.